the GS and GI coupled receptor. So suppose this is your myocardial cell, okay, and here is the beta receptor and here is the M2 receptor. Okay, see, both beta receptor as well as the M2 muscarinic receptor, both these receptors are an example of G protein coupled receptor, and these are present on a myocardial cell. The action of beta receptor is when it gets activated, it increases the heart rate, whereas the M2 receptor, when it gets activated, it reduces the heart rate. Okay, this is adenylyl cyclase. It is the enzyme, or you can say it is the effector in this case. This is a calcium channel and this one is a potassium channel. Now this beta receptor, it is an example of GS, that is G stimulatory kind of receptor, whereas this M2 receptor, it is a kind of GI, that is G inhibitory receptor. Means GS receptor, GS kind of G protein coupled receptor will have got some sequence of effect which will always cause stimulation, whereas GI kind of G protein coupled receptor, it will also have got some different kind of sequence of effect, and the final result will be it will cause inhibition of the action. Okay, now we'll check out one by one. First of all, we'll start with GS type of G protein coupled receptor. Now suppose adrenaline binds to the beta adrenergic receptor on the cell surface, and it will induce a conformational changes which will permit the interaction of the G protein binding site with the stimulatory G protein. So this activated GS, it will now displace the GDP and it will be replaced by GTP. Okay, the very first event followed by the ligand binding is GDP, that is guanosine diphosphate, will be replaced by guanosine triphosphate. Next, this GTP along with the alpha subunit, it will be moving to the adenylyl cyclase enzyme, which is our effector, and it will cause activation of this enzyme. When this enzyme will get activated, what will this enzyme do? The ATP is hydrolyzed to cyclic AMP, and this cyclic AMP, it will cause phosphorylation and activates the cyclic AMP dependent protein kinase, that is pKa. Even the calcium ion is made available by the entry through the calcium channels. Next, this pKa, it will phosphorylate many functions or many functional proteins including the troponin and phospholambin, so that they interact with the calcium. Okay, so that action is the interaction of calcium with this troponin and phospholambin. See what is happening till now. Adenylyl cyclase is get activated, and what this enzyme will do, it will convert ATP into cyclic AMP. Next, what this cyclic AMP will do, it will cause activation of the protein kinase. Okay, next, what is the activity of protein kinase? Protein kinase will produce influx of calcium from the calcium channel, plus it will cause activation of two important proteins, that is troponin and phospholambin. Okay, now the incoming calcium, it will interact with troponin as well as phospholambin. Okay, so troponin along with calcium, it will result in better excitation contraction coupling, and therefore it will increase the cardiac contractility. Whereas phospholambin interaction with the calcium, it will cause increase, or there will be faster sequestration of the calcium in the sarcoplasmic reticulum, therefore there will be faster relaxation. So contraction is also fast, relaxation is also fast, so you can say the force of contraction increases and even the heart rate also increases. So this is how the adrenaline will increase the force of contraction as well as the heart rate. So we will revise the thing. What has happened till now? The receptor was normal, it was under resting condition, and eventually when the adrenaline bound to the beta receptor, what happened? first thing that happened is guanosine diphosphate was been removed and it was replaced by guanosine triphosphate. Next, this guanosine triphosphate along with the alpha subunit, it left the receptor and it moved to the effector. The effector over here is AC. AC is the adenylyl cyclase enzyme. And now this enzyme got activated and it started producing its catalytic action. Okay, and what is the action of this enzyme adenylyl cyclase? Its action is it catalyzes the conversion of ATP into cyclic AMP. Now cyclic AMP is our second messenger. Now all the thing is on the shoulder of cyclic AMP. What the cyclic AMP is doing? It is causing activation of the enzyme protein kinase. And what this protein kinase will do? Protein kinase does two important things. First of all, influx of calcium ion from the calcium channel, and second thing is activation of the protein, that is troponin and phospholamine. Now our proteins got activated and we have got calcium ions as well. So next thing or next step will be interaction of these protein with the calcium ions. Okay, so calcium ion when interacted with troponin, it increases the cardiac contractility. Phospholamine interaction with the calcium ion, it increases the relaxation rate. So contraction and relaxation both are increased, therefore both together it will increase the force of contraction and increases the heart rate. So this is about the G protein coupled receptor, and over here we were discussing about the GS, that is G stimulatory kind of G protein coupled receptor. Now we will discuss about the GI type of G protein coupled receptor. A very simple example is the muscarinic M2 receptor. Now suppose acetylcholine binds with the M2 receptor. So initially same thing happens. Guanosine diphosphate will be removed and it will be replaced by the guanosine triphosphate. Now this guanosine triphosphate along with its alpha subunit, it will be moving towards the effector. But what is happening to the effector now? Whether it will stimulate or inhibit? Yes, it will inhibit because it is G inhibitory kind of G protein coupled receptor. So it will inhibit the adenylyl cyclase. Now when enzyme is inhibited, there won't be any conversion of ATP into cyclic AMP. There won't be any protein kinase. Nothing will be happening. Just stagnant. Plus, in addition to this beta gamma subunit, it will move towards the potassium channel and it will cause opening of the potassium channel. Once the potassium channel opens up, whatever potassium ion this cell have got, it will be moving outside. And we know that what happens when in a cell there is excessive loss of potassium ion. Yes, the cell will become hyperpolarized. Hyperpolarized means still the force of contraction and the heart rate will be reducing. So in this manner you can see whenever the G protein coupled receptor is a kind of GS, it will stimulate everything. The force of contraction is increased, the heart rate is increased. But when the G protein coupled receptor is a kind of GI type, so GI type is a inhibitory kind of G protein coupled receptor. So it is inhibiting the heart. Inhibiting the heart means it is reducing the heart rate and it is reducing the force of contraction. Okay, so this is a very simple example for explaining the GS and GI type of the G protein coupled receptor.